morning, boys and girls, and welcome to this live session on winning techniques brought to you by TalentSprint. I hope all of you are in good health and you are preparing fully in the right spirit and with the right strategy for your upcoming bank exams, right? More importantly, the IBPS Clerk's preliminary exam and the RBI Citizens preliminary exam, which is like 3 weeks away now, right? I see that a lot of you have already joined this session here, and I hope all these winning techniques that we are doing at 11 a.m. every day are helping you get that confidence before you walk into the examination center for taking these highly competitive exams, right? Let me tell you that the IBPS PO mains exam is also scheduled on the 26th of this month, 26th of November. So all those who have cleared the IBPS PO preliminary examination can join us in our free live sessions for the IBPS PO refresher, main exam refresher, brought to you by Govt and TalentSprint together, right? These sessions are held at 6 p.m. in the evenings of Tuesdays and Thursdays. Okay, if you want to know more about these sessions, please do subscribe to our YouTube channel and you'll get notified about all the live sessions that we do and all the videos that we upload. All right, on that point, let me now get started with this session. Like you all know, today is another session on winning technique, and we'll discuss something on quantitative aptitude. In fact, we'll be discussing about compound interest, which is one of my favorite concepts from the subject of quantitative aptitude. Now, I know that many of us, or most of the students, in fact, struggle to deal with compound interest, right? It's a complex calculation. It's a compounded calculation, right? It's not as simple as simple interest, right? Like the name says, simple interest is simple, and compound interest is not simple. I mean, it's compound, right? It's a compounding process. You know that every year you calculate the interest and that interest gets added back to the principal amount. Again, for the second year you calculate the interest. This new interest gets added to the principal amount, right? Gets added back to the principal amount. So this is a compounding process. Let me not get into the details. I'm sure you know really well about it, right? And I'm also hoping that you will subscribe to our YouTube channel and maybe explore our online programs to watch these things in detail, right? Where all these concepts have been covered in detail. But what am I going to explain you today is the whole idea of solving questions related to compound interest without using the formula, right? All of you know the formula for the calculation of compound interest, right? P into 1 plus R by 100 whole to the power of T minus P, or if we take P common, we get 1 plus R by 100 whole raised to the power of T minus 1, where P is the principal amount, T is the time period, and R is the rate of interest. Now, do we really need to use the formula always? No, not really. Ramakrishna has just mentioned that compound interest is equivalent to struggling to, he struggles to solve this every time. And I'm sure there are many others like Ramakrishna. So let me make this a concept simple for all of you, and the fact that we can make compound interest simple goes to show that even simple interest can be made a lot more simpler, right? But anyway, we'll focus on CI today, compound interest. So the idea is, how do you solve questions related to compound interest without using the formula? What I'll do now is present a simple question to you, very simple straight question. Principal, time period and rate of interest are given. You are required to calculate the compound interest. Try and get the answer first and then we'll discuss the concept. So the first question for the session today is on your screens now. See what it says. What would be the compound interest? What would be the compound interest obtained on an amount of rupees 12,400 at the rate of 15% per annum after 2 years? So you have been given the amount, the principal amount, the rate of interest is 15% per annum, and the time period is 2 years. He's asking us to find out the compound interest. Now I'm sure all of you will get the right answer, but the question is, how quickly will you get the right answer? Right? How quickly do you arrive at the answer? Some of us will solve this in 30 seconds, some will take 1 minute, some will take 2 minutes. Why does that happen? Because we are dealing with a formula here. Which makes it a little time consuming, right? Okay, answers have started coming in. 3999, 3860, yeah, 4012. So see, I've got 3 different responses already. 3860, 3999, 4012, all of which are there in the options. What will be the compound interest obtained on an amount of rupees 12,400 at the rate of 15% per annum after 2 years? Okay. Chalo, let's solve this now. So here we go. Let us solve it using the regular method first, right? You know what is the formula for CI, right? Compound interest, CI, can be calculated as, if you take P common there, it is 1 plus R raised to the power of 100 whole to the power of T minus 1. I mean, this is the formula, if at all you want to go by the formula there. So let us substitute the values. You have been given all the three values, right? A simple question. See, do not expect that such questions would be asked in the exam these days, right? You will not be asked such questions even in clerical exams these days, but then the concept is important. This concept will be useful in solving one part of a question in the exam these days, right? So you should know how to use the SMART technique for even the simplest of the questions, right? Anyway, so the principal amount is 12,400, right? We have to find out the CI obtained on an amount of rupees 12,400. So this is the principal amount at the rate of 15% per annum, right? This is the rate of interest R, and after 2 years. So the time period is 2 years. So all the three have been given to us. Just solve it now. So what happens? Principal is 12,400 into 1 plus R by 100. Rate is given as 15. 15 divided by 100 whole to the power of 2 whole raised to the power of 2 minus 1. Now do this calculation. So 12,400, I mean, you can cut down a few steps while simplifying this and maybe arrive at the answer a little faster. Now this will be like 100 plus 15, 115, 115 by 100, right? 115 by 100. So 115 by 100 whole squared minus 1, right? Now if I simplify, this is like 5 into 20, 5 into 23, right? 23 by 20 whole square. 23 square is 529, 20 square is 400, right? So solve this. Solve this now. So 12,400, if I take it as 529 by 400 minus 1, so that will be 529 minus 400 divided by 400. Okay. Now if you try and cancel this, 400 goes how many times? 400 goes 31 times here, right? 400 into 30 is 12,000. 400 to 1 is 400. So this goes 31 times, right? 31 into 529 minus 400 is 129. So basically your final answer is 31 times. I'm sorry. The final answer is going to be 31 times. It is equal to 31 into 129. 31 into 129. Simplify this, we'll get the answer. Now if you go by unit digit method, you know that the answer will end with 9. One value ends in 1. One number ends in 1. The other number ends in 9. So the product will end with 9. So option 1 which ends in 2 gets eliminated. Option 2 which ends in 0 gets eliminated, and option 4 also which ends in 2 gets eliminated. Answer can either be option 3, 39999, or fifth option, none of this, right? Now I'm sure you can do the calculation. You will find that this is equal to 3,999, right? So option 3 is going to be the final answer. But then this is a cumbersome process. I mean, time consuming, too many steps involved, and it depends on your numerical skills again, right? Maybe if you can do the calculation faster, you will save some bit of your time there. Okay, but 3,999 is the answer. Now how do you solve this without using this complex formula, right? Without using this formula. So let me explain that part to you. Now there is this concept of effective percentage that we have discussed in the topic of percentages. Effective percentage. Effective percentage for two different percentages can be taken as A plus B plus AB by 100. I am not going into the detailed discussion because all this has been covered in detail in our videos of TalentSprint's program. You can just refer to that. But the idea is effective percentage. It's a very, very important concept. In my view, the most important concept in the entire subject of quantitative aptitude, right? Can help you save a lot of time across many topics. So effective percentage is equivalent to A plus B plus AB by 100, where A is the 1% and B is the other percentage. Now the point is, the same effective percentage formula can also be used to calculate compound interest. This effective percentage is nothing but it is equivalent to the compound interest in terms of percentage. Whatever you get as effective percentage is the compound interest in terms of percentage. See, what we have got here is the compound interest in absolute value, 3,999. But this formula will give you the compound interest in terms of percentage. When you take that percentage on the principal amount, you will get the answer directly. Right? So let's take this up now. Now what are A and B? Basically A here is the rate of interest for the first year and B is the rate of interest for second year. So when you have been given the rate of interest for first year and second year, you can find out the overall compound interest using A plus B plus AB by 100. If you look at this question, he has mentioned that the rate of interest is 15% per annum. and the time period is given as 2 years. Now, since he has not specified anything in particular here, we can assume that the rate of interest is same for both the years. First year 15% and second year also it is going to be 15%. So I can say that A is equal to B is equal to 15. In our case, A is equal to B is equal to 15. So what is going to be the compound interest now? Find out in terms of percentage. 15, A is equal to 15, B is equal to 15, and 15 into 15 by 100. Simplify this. See, 15 plus 15 is 30. 15 into 15 is 225. 225 by 100 is 2.25. So 30 plus 2.25, 32.25. So basically the idea is that the compound interest is going to be 32.25%. Of what? Of the principal amount. Remember, in case of SI and CI, simple and compound interest, all the calculations are done with respect to the principal amount. So we can conclude that CI, the compound interest CI is equal to 32.25% of the principal amount 12,400. Now again, your calculation skills are important, your numerical skills here are important, right? How do you do the calculation? So if I have to explain you the calculation part here, what we can do is 32.25% can be split as 30% plus 2% plus 0.25%. Yes or no? Either convert this into a fraction. Now I don't recall 32.25 in terms of any fraction there. I mean, it cannot be taken, of course it can be converted to a fraction, but then not so easy to do, right? It's not a standard percentage in terms of its equivalent fraction. So what we can do is, we can split this in terms of 32 and 0.25. So that the calculation becomes easy. Now 30% of 12,400. See, what is 10% of 12,400? 1240. 10% is 1240. If 10% is 1240, 30% will be 3 into 1240. 3,600 plus 120, 3,720 plus 2%. What is 2% of 1240? See, 2% of 12,400, 1% is 124. 1% is 124. So 2% will be double of that, 248. Plus 0.25%. Now what is 0.25%? See, 0.25% can be taken as 1% by 4. What is 1% of 12,400? 124. 124 by 4. 124 by 4 is 31. That's it. Add these three values, you'll get the answer. So 3,700 plus 200, 3,900, 20 and 48, 68, 68 and 31 is 99. So 3,900 plus 99, 3,999 is the answer. Well, some of you may still feel that this is the better way of doing it, right? Even this involves the same amount of calculation, but then the idea is, see, a lot of these steps can be avoided here. Like the calculation that we have done on paper is not really needed. You can do this mentally, right? 15 plus 15 plus 15 into 15 by 100 is very easy to solve. You can do that mentally. Like for example, let's assume that the rate of interest is not 15. If it is 16%, what do? 16 plus 16 plus 16 into 16 by 100. Now, do you really have to write this on paper? No. 16 and 16 is 32. 16 squared, is 256. 256 by 100, 2.56. So 32 plus 2.56, 34.56. So without having to write anything on paper, I will know that the compound interest is going to be 34.56% of the principal amount. Now do that percentage calculation and you will get the answer straight. Are you able to follow? Do that calculation and you will get the answer straight without using the actual compound interest formula there, right? P into 1 plus R by 100 whole to the power of T minus 1. Now, for example, let's say the rate of interest is 7% per annum. What will be the compound interest for 2 years? Rate of interest is 7% per annum. We need to find out the compound interest for 2 years. What do? 7 plus 7 to 7 by 100. So 14 here and 0.49 here. 7 squared is 49 upon 100 is 0.49. So 14.49%. 14.49 is approximately 14.5%. Approximately 14.5% of that principal amount will give you the answer, right? Similarly, let's say the rate of interest is 20%. Simple calculation, 20%. What will be the compound interest? 20 plus 20 plus 20 into 20 by 100. So 20 plus 20 is 40. 20 into 20 by 100 is 4. 400 by 100, 4. 44% will be the answer. 44% will be the answer. I'm sure a lot of you are now wondering, how do we do it for 3 years? Will the same formula be useful for 3 years? I'll come to that. That's a very big question, or a very common question that students usually ask. We'll look at one question for 3 years as well, but first get the idea correct for 2 years. How do you use it for 2 years, right? Let's say the rate of interest is given as 24% per annum. 24% per annum. What do you do 24% per annum? What is the compound interest for 2 years? 24 and 24 is 48. 24 squared by 100. What is 24 square? 576. 576 by 100, 5.76. So 48 plus 5.76. 48 plus 5.76 is 53.76. So I know that the compound interest is going to be 53.76% of the principal amount. I look at the options first. Look at the options first. Decide which option looks like 50% plus. You understand? If the options are closed, if the options are like spaced very close to each other, then you will have to do a precise calculation. If the options are not too close, then maybe you can avoid doing the exact calculation, right? Approximately, you can find out which of the 5 options are correct. You're getting it? So just try and understand that this effective percentage concept is very, very useful, and useful not just for CI, useful in many other topics. It can be used in time and work. It can be used in time and distance. It can be used in profit and loss. It can be used in mensuration. It can be used in data interpretation. Wherever you got to, do an effective calculation for 2 given percentages, right? So that's the idea. Rate of interest is given to you, time period is given to you 2 years, apply A plus B plus AB by 100. Now similarly, let's say that the rate of interest is different. Then what happens? Let me go back to the screen and explain this to you, right? Here in this case, we have found that the rate of interest is 15% for both the years. But let's say the rate of interest is not 15% for both the years. Let me just clear this up, right? You've got the answer as 3999. How do we calculate? CI is equal to A plus B plus AB by 100. So that's the idea of the principal amount. This is what you need to remember. What is A here? A is the rate of interest for first year, and B is the rate of interest for second year. Most of the times the rate of interest, rate of interest for first year and second year are same. But let's take a special case. He says what would the compound interest on a particular amount where the rate of interest for the first year is 15% and for second year it is 20%. Instead of 2 years, he says rate of interest is 15% per annum for first year, right? And 20% per annum for second year. Do you have to remember a new formula? No. The same formula is applicable, right? What do? A is equal to 15, B is equal to 20. Do that calculation. 15 plus 20 plus 15 into 20 by 100. Now 20 by 100 is, goes 5 times, and this is 3. So basically 300 by 100 is 3, right? Now 15 plus 20, 35. 35 plus 3, 38. So I know that the answer is going to be 38%. 38% of what? Whatever the principal amount is. 38% of 12,400 in this case. Right? 38% of 12,400. Right? Similarly, he may say that the first year rate is 12%, second year is 15%. You can do that mentally, but still, if you want to understand it clearly, just put it on paper initially. Once you are comfortable using the concept, using the technique, then you can try for mental calculations. So 12 plus 15 plus 12 into 15 by 100. Now I know that this is 1.8. 12 into 15 is 180. 180 by 100 is 1.8. 12 and 15 is 27. So your answer will be 28.8%. 28.8% of what? Of the principal amount. 28.8% of the principal amount. You're able to follow? Let's say the rate of interest for both the years is given as 19%. For both the years, it is 19%. What do? 19%. Now, mentally, you have to do this calculation. Don't put pen on paper. 19 plus 19, 38. Remember this value. And 19 squared by 100. What is 19 squared? 361. By 100 is 3.61. So, your answer in this case will be 41.61%. Do an approximate calculation. Again, it depends on the options. But do an approximate calculation. 41.61% of the principal amount. So, this is how you can solve questions based on compound interest using effective percentage. Now, what we have discussed so far is only for 2 years. We will move to a 3-year question in a while, right? But if you're clear with this, I can just go for the next one. Are you all clear with this idea? A plus B plus AP by 100, where A is the rate of interest for first year and B is the rate of interest for second year. Harshil Patel has asked me a question that can we use this formula to calculate percentage change? No. Percentage change is different. Percentage change should be taken as final value minus initial value upon initial value into 100. When there are 2 values given to you. See, percentage change can be calculated for 2 absolute values, 2 proper numbers, right? Percentage is not an absolute value, right? This formula is applicable only for percentages, where A and B, remember, A and B both are percentages, right? A and B both are percentage. Only then you can use it. But percentage change is a different concept. Percentage change is difference by initial value or final minus initial by initial value into 100. Okay, now let's go to the next question based on the 2 years again, right? Asked slightly differently, and then we will look at a 3-year problem. Okay, so the next question is on your screens now. Look at this. This time he says the compound interest accrued in 2 years on a principal amount of 16,250 is rupees 5,616. What is the rate of interest per annum? So this time, instead of asking us to find out the compound interest, he's asked us to find out the rate of interest. But what has he given? He has given us that the time period is 2 years, the principal amount is 16,250, and the compound interest is 5,616. 5,616. Solve this now. Try to solve this. What's the answer? He's asked us to find out the rate of interest, right? The compound interest accrued in 2 years on a principal amount of 16,250 is rupees 5,616. What is the rate of interest in percentage per annum? Right? Similar question, but instead of giving us the rate of interest and asking us to find out CI, he has given us the CI, and we need to find out the rate of interest. What is the rate of interest in terms of percentage per annum? Right? Okay, answers have started coming in. 22% is what many of you have marked already, right? Harish, Mahananda, Naresh, Pradeep, Sai, and others. But then we have Shubhank and Suhas who've got 16%. So there's some confusion out there, which will get cleared in the next couple of minutes. But I want more of you to respond to this question first. You have 1 more minute to crack this. All you have to do is go back to that concept of effective percentage, A plus B plus AB by 100. All right, 15 seconds to go. Okay, looks like a majority of you have got 22% is the answer, which looks incorrect, but we'll figure that out once we start solving it. Issue is sure that 16% is the right answer. Okay, so let's take it up now. So he says the compound interest in 2 years on a principal amount of 16,250 is rupees 5,616. What is the rate of interest in terms of percentage per annum? Okay, now try and understand that the principal amount is 16,250 and the compound interest is 5,616. All I have to do here is find out the compound interest in terms of percentage. See, the effective percentage formula gives you CI in terms of percentage, right? It gives you the CI in terms of percentage, and that percentage, when you take on the principal amount, you will get the actual CI in absolute number. Here, the actual CI is given to us in the absolute value. All you have to do is try to convert this into percentage, which means we have to find out that 5,616 is what percentage of 16,250. That will give us a CI in terms of percentage, and that can help us find out the answer very quickly. Right? So let's try and find out 5,616 is what percentage of 16,250. Right? So basically, we will write CI in terms of percentage. What is the compound interest in terms of percentage? How do you calculate that? I have got 5,616 rupees on an investment of what? 16,250 rupees into 100. Simplify this. You can do an approximate calculation. You need not do a precise calculation. So look at the options here: 22, 16, 18. Right? Cannot be determined is anyway ruled out, because answer can be determined. I mean, when 3 variables are known to us, answer can easily be determined. So cannot be determined is wrong. It could be 1, 2, 3 or 5. But then options are not too close, right? 16%, 18%, 22%. You can do an approximate calculation also if you want. So try to find out
this percentage value. Try to find this percentage value. So if I try and break this up in terms of the denominator, see, I have explained how to do how to simplify such percentage calculations, right, in our percentages video. Always treat the denominator as 100%. What we'll always do is consider the base to be 100%. The base here is 16,250. So assuming that 100% is 16,250, you have to find out 5,616 is what percentage. So the idea is this. See, I'm writing too many things on paper, but you can avoid it. But the point is, see, 10% is equal to 1625, which means what will be 30%? I'm trying to come as close as possible to 5,616, which means 30%, 3 into 10, 30% is equal to, this will be 4,875, 4875. But we are still more than that. We're still more than that. 5616 is more than 4875, right? So if I break this up, what do we get? I mean, see, all this has to be done mentally, right? Don't go by the number of characters which are being written on paper there, right? 5,616 can be taken as 4875 plus I have 125 here and 616 here. So that's like 716, 741, right? 741. 5616 has been split as 4875 plus 741. I know that 4875 is 30%. Now what is 741? See, the denominator is 16,250, which means 10% is 1625. This is, you understand, what is 5%? See, try to get the range. The whole idea is to get the range. What will be 5%? 5% is going to be 812.5. This is less than 812.5. I have already got 30% here. Now what is 741? 741 is less than 812.5. So I can say this is less than 5%. Less than 5%. So overall, if this is 30 and this is somewhere less than 5, it will be around, it will be somewhere around 33, 34, let's say. Right? 33, 34%. Now what value can give you a compound interest of 32% for 2 years or 34% for 2 years? See, if I take 22, what happens? Apply a plus b plus ab by 122. 22 plus 22 plus 22 into 22 by 100. That 22 plus 22 itself is 44. 22 plus 22 itself is 44. Can this be the answer? No. Because if rate of interest is 22, my compound interest should be more than 44%. Here I am getting the compound interest as less than 35%. 30% plus less than 5%, less than 35. So option 1, 22 is ruled out. You understand? 22 is ruled out. Can I take 18? See, if you take CI, I mean rate of interest as 18, compound interest will be 18 plus 18, right? 18 plus 18 plus 18 into 18 by 100. Now 18 plus 18 itself is 36. Here we have got less than 35, so 18 cannot be the answer. Now there are only two choices. Either you take option 2 as the answer or option 5, none of this. What is option 2? 16. Verify option 2 also. 16. If you take 16, 16 plus 16, 32 and 2.56. Sorry, 16%. Try and apply effective percentage for 16. I mean, try to find out the compound interest if the rate of interest is 16%. What happens? 16 plus 16 plus 16 into 16 by 100. That gives you how much? 32 plus 2.56. 32 plus 2.56 is 34.56. 34.56. Yes or no? Is it not in this range? If I take 16, sorry. If I take 16, I'm getting 34.56. Looks like 16 is the right answer. 16 is the right answer, right? So, I mean, of course, you can still, argue that fifth option, none of this is there, and we may have to do a precise calculation. If precise calculation has to be done, there is no other shortcut. You do the complete calculation or maybe use the formula. If you are so particular about getting the right answer, only then you will mark it, then you better use the formula. What is the formula? Ci equals to P into 1 plus R by 100 whole raised to the power of T minus 1. Use this formula and you will figure out how complex is this, because this time you have to find out R. It will take even more time. So if you are so precise, I mean particular about the precise answer, exact answer, then use this formula. If you are ready to take a chance, I would mark option 2 as the answer. It looks like option. I mean, 1 is wrong, 3 is wrong, 4 is wrong. Either 16 or fifth option, none of this. And 16 looks like it is 16. Maybe one more verification that can be done is apply 34.56% on 16,250. If that comes out to be 5616, that's the answer. You're able to follow? I mean, we are doing a approximate calculation. We are doing an approximate calculation to find out which of the options are wrong, right? Definitely 1, 3 and 4 are wrong. It could be 2 or 5. Now I know that it will not be very comfortable initially, right? Many of you must be feeling that it's complex, but that is more to do with your numerical skills and not with the concept here, right? Because if you're good with numbers, you can use any, I mean, if you're good with numbers, even the formula can be used, right?
So the point is you have to be very quick in analyzing these numbers, right? I mean, you should know that, okay, very quickly, if you can find out, if you can figure out that the answer is less than 35%, the CI in this case is less than 35%, then immediately 1, 3 and 4 are ruled out. Only 2 or 5, right? Mark one of those as the answer. I mean, I would take 16% as the answer. That amount of risk has to be taken. Otherwise, if you want exact answer for every question, then it may get very time consuming. And going by the formula definitely is not the way to do it, right? I mean, we can maybe derive one more shortcut formula for finding out the rate of interest, but how does it help? Not really. So that's the idea, A plus B plus AB by 100 for finding out compound interest. Now let's go to the next question, where the time period is 3 years, and I'm sure many of you have been waiting for this, right? How do you solve compound interest for 3 years using the same formula? So let's look at the next question. Now I've taken a simple one. The values are all simple because I want all of you to be comfortable with the technique first, and then we will do more complex ones. Yeah. So here's the question. Here is the question. It says, what would be the compound interest obtained on an amount of rupees 2,000 at the rate of 12% per annum after 3 years? So this time the principal is 2,000, right? Principal is 2,000. Rate of interest is 12% per annum, but the time period is 3 years. The time period is 3 years. Now solve this first, and then we will look at the smart method. By the way, in the previous question, you can maybe also do a unit digit verification if you want. Like, I mean, sorry about this, but if you want to verify using unit space method, you know that if the rate of interest is taken as 16%, compound interest will be 34.56. 34.56% of, you understand, 34 point, you have to just do that, apply that unit space method on 34.56% of 16,250, right? And check if unit space is matching with the given compound interest or not. Okay. Chalo, back to this one now. So what would be the compound interest obtained on an amount of rupees 2,000 at the rate of 12% per annum after 3 years? Okay, options doesn't really matter in this question because you know, if you really have to go by options, within 5 seconds you will know that the answer is option 3, right? Let me explain this to you now. The point is, he's asking us to find out CI for 3 years. Time period is 3 years. The rate of interest is 12% per annum. Now, even if I take simple interest, SI, what will be the SI? See, every year you are going to get 12%. So in 3 years you'll get what? 12 plus 12 plus 12. You'll get 36%. 36% of what? 2,000. 36% of 2,000 is 720. Now you very well know that compound interest is always more than simple interest for the given rate of interest and principal amount. CI is always more than SI. So clearly compound interest should be more than 720. So immediately option 2 is ruled out. 550 cannot be the answer. And it won't be going in the range of 1400, 1250, 1120 and all, right? See, 1400 is 70% of 2000. 1250 is, 60. 2.5% of 2000, right? 1120 again is 56% of 2000. Will it go to 56%? No, it will be slightly more than 36%. So if you have to go by that kind of elimination, 1, 4, 5 and 2 are eliminated. Only option 3 is left out, which can be taken as the correct answer. Because SI comes out to be 720, CI will be more than that, a little more than that. It won't go to, it won't become double of 720. Or close to double of 720, right? So 810 looks to be the right answer. However, if you have to solve it properly, let's say if options are very close to each other, if all the options are in the range of 800, then how do you solve it? What do? Use the same formula. You know that CI in terms of percentage is A plus B plus AB by 100. Right? Percentage of the principal amount. The only difference is this time we have 3 years. Instead of 2 years, we have got 3 years. So what do? It's like this. 12% in the first year, 12% in the second year, and 12% in the third year. First of all, apply A plus B plus AB by 100 for the first 2%. Apply A plus B plus AB by 100 for the first 2%. You will get the CI for 2 years. Then whatever result you get here, use that along with the third percentage
and again apply a plus b plus ab by 100. So the simple concept is the same formula has to be used twice. It's like finding out HCF, right? How do you find out HCF of 3 numbers? Highest common factor of 3 numbers. You'll first find out the highest common factor of 2 numbers. Then the result and the third number are considered and you find out the new HCF. So the same process has to be applied here. Take the 2 percentages first. Apply a plus b plus ab by 100. How much will that be? 12 plus 12 plus 12 into 12 by 100. So 24 plus 1.44. 25.44. This will give you 25.44 percentage. Mental calculation, right? A plus b plus ab by 100. 12 plus 12 plus 12 into 12 by 100, right? 12 plus 12 is 24. 12 into 12 by 100 is 1.44. So this comes out to be 25.44. Now use this 25.44 along with this third 12 percentage. Apply formula now. A plus b plus ab by 100. So 25.44 plus 12 plus 25.44 into 12 divided by 100. Solve this, what happens? See, approximately if I take this as 25, it goes 4 times and this gets cancelled 3 times. So 25 plus 12, 37 plus 3, 40, 40 plus 0.44, 40.44, 40.44 or slightly more than 40.44. Yes or no? So I can say approximately the answer is going to be 41%. Let's say approximately 41% or something more than 40%, right? So CI in this case is going to be approximately 41% of whatever principal amount, which is 2000. What is 41% of 2000? 820. Which is the closest option? Option 3 is the closest one. So option 3 can be taken as the right answer. You understand? Option 3 is the right answer. So this is how you got to do. Similarly, if it is for 4 years, the same concept can be used. First of all, we will not usually get questions on CI for 4 years, but in case if you get it, the same concept has to be used thrice, right? But anyway, let us take one more question for 3 years. Let's say the rate of interest is, 16% per annum for 3 years. 16% per annum for 3 years. How do you calculate CI now? See, CI will be 16 and 16. We have got 3 16s now. So apply effective for first 2 16s, 32 and 2.56, 34.56. I think we have already done this calculation. Now 34.56 and the third 16%. Again on these two you apply effective percentage. So 34.56 plus 16 plus 34.56 into 16 by 100. Of course, you got to do an approximate calculation because doing the exact calculation will consume a lot of time, but you will know what will be the range of the answer. So 34.56 plus 16 is 50, 50.56. How much is this? If you say this is approximately 35, let's say, it goes 7 times and this goes 20 times. So, and this is like maybe again 4 by 5. So 28 by 5. 28 by 5 is 3.6, right? 28 by 7 4 28. 28 by 5, right? 28 by 5 is 5.6. So maybe 5.6 and 34.5 can be taken as 40. 40 plus 16 is 56. So approximately 56%. I can say that the answer is going to be 56% of the principal amount. Yes or no? So this is how you do it for 3 years. Okay. Now what happens if it is for 4 years? 4 years is a lot simpler. It looks to be complex, but let me tell you, 4 years will be easier to do. You actually don't have to apply it for 3 times. For example, first of all, we should not even attempt a question where compound interest for 4 years should be calculated. But let's say the rate of interest is given as 12% per annum for 4 years. What happens? There are 4 12s. You just have to ensure that effective percentage is used on all the 12s given here. So I'll apply a plus b plus ab by 100 here. How much will I get? 25.44. Now instead of applying 25.44 and 12 next, you better apply it here. But the point is, if the first 2 12s have given you 25.44, the next 2 12s also will give you 25.44. And now apply effective on these two. So 25.44 plus 25.44 plus 25.44 into 25.44 divided by 100. You're getting it? So this is like 50.88. How much is this? If I say approximately, let's say 25, this is 4 times. And 25.44 by 4 will be 6.3, let's say, right? 6.3 or 6.4. So 50.88 plus 6.4. That's going to be somewhere around 50.9 and 6.4. So 56.9, 57.3, approximately 57.3%. I look at the answer options. If there is only one option which is in the range of 57, 58%, I'll mark that as the answer, right? So always decide if you want to solve the question or not based on the answer options. If these are the type of options given to us, then you should definitely solve it, because an approximate calculation will lead you to the correct answer, right? You don't have to do a very precise calculation. So this is how effective percentage A plus B plus AB by 100 can be used for solving questions based on CI. Now, if you say this is time consuming for 4 years, try the formula. This is one formula, right? CI equals to P into 1 plus R by 100 whole to the power of T minus P. Or if you take P common, CI is equal to P times of 1 plus R by 100 whole to the power of T minus 1. Use that formula and you will get the answer. That also, if that is not time, see, use what is comfortable for you. I am not saying you have to always follow this method. No, it's not a hard and fast rule that you should do this, right? You need not do this. If you think the formula is better, go for the formula. Find out what is working for you, right? All of us need not be comfortable using the same method, right? Some of you are better off using the formula. Go for it. If this method takes 10 seconds and the formula gives you the answer in 9 seconds, you should use the formula. You should definitely use the formula, right? If this method takes 10 seconds, if the formula takes 9.5 seconds, even then you should use the formula, because you are saving half a second there, right? So you decide what is comfortable. Before complaining that this is time consuming, you actually compare. Do the same question using the formula and using this concept and see which one works for you. Remember, all this depends on your numerical skills. If you are not good with numbers, if you cannot work on your calculations, then it's gonna be difficult, right? You have to be very good with your numbers, right? So that is the reason, I mean, from day one I've been telling you, right, guys, 45 minutes, 1 hour every day, practice on calculations. Only then you can score more in the exam. All right, so that's about the winning technique for the day, right? A plus B plus AB by 100 gives you the compound interest in terms of percentage. Apply that percentage on the principal amount to arrive at the answer. Whether it is 2 years, 3 years, 4 years, 5 years, you can always use the same formula. It's just that you have to use it multiple times depending on the number of years that we have, right? Again, you cannot use the formula if it is a if it is a half yearly compounding, or you cannot use the formula directly if it is a half yearly compounding or quarterly compounding, right? You know that there is a concept of half yearly compounding, quarterly compounding. There also the formula can be used, but you'll have to first change the percentage and change the number of intervals that you have. Again, all these things have been discussed in detailed videos at on TalentSprint's program. You can just refer to that. But the point is, yes, this is a very, very useful concept, and the application is not just limited to CI. It is applicable in many more places. So just try and figure out where all you can use effective percentage and make your life simple. On that note, let me sign off from this session today. I hope all of you have enjoyed this. Please do not assume that this is complex or this is time consuming just based on what we have discussed today. I was explaining it to you, so it has taken so much of time. When you do it yourself, you'll get the answer faster. But before that, you need to practice, right? Learning this alone is not going to help. So practice a little more, then I'm sure you'll find it very, very useful. So keep practicing and take very good care of yourselves. We'll meet again tomorrow at 11 a.m. with one more winning technique from quantitative aptitude or reasoning that can help you save your precious time in the exam. See you tomorrow. Take care.